Hey guys, it's me again. Today your homework is going to be on the green paper. You are going to want to go get two different colors, and I didn't really think about that when I put it on green. Go ahead and pause it now, and then come back when you've got the stuff. So what we're going to be talking about in 5.2 is we're going to be talking about substitution. The idea behind what we're doing is very similar to graphing. We're still looking for that point of intersection. There's still going to be a one solution, a multiple solutions, or infinite solutions, and then no solutions. So today our essential question is, how do I solve systems of equations by substitution? So when we were looking at these, we were graphing a line, graphing another line, and then finding that spot. And then when we came down here and we started to verify, basically what we're going to be doing now is we're going to be doing more algebraic work than the graphing work. So there's 3 steps. These are the basic 3 steps that it doesn't matter which kind of equation that you are looking at. The first step is we're going to solve one equation for either x or y. And what that means is that we want to make sure that one of these equations says y equals or x equals. So we'll be kind of talking about that in the first step down here. The second step is going to be, we're going to substitute the solution into the second equation. And solve for the opposite variable. So we're going to substitute the solution. When we solve an equation for x or y, we're going to substitute that solution, so whatever it equals, into the second equation. And we'll talk about an example of that here in a second. And then we're going to solve for that opposite variable. So if we solve for x, whatever x equals, we can plug it in, and then we'll solve for y. And then finally, we're going to use the solution from step 3 or 2 into original equation and solve for that variable. And I think the steps will make more sense when we start kind of going into what we're doing. So for those of you that aren't really sure, I've used this word now twice. So what does substitution actually mean? And so when I think of substitution, I think of like a basketball game or a hockey game where there's players out, and then the coach says, we're going to make a substitution. So they call a timeout. They take out a player and they put in a completely different player. So the definition of what substitution means is it means to replace something for something else. And in sports, it's generally players. Okay, so we're going to go through these. So these are 4 different equations. 2 of them are one answer equations. There's a no answer equation and an infinite answer equation, and we're going to talk about that in just a second. So the first thing that you want to do is you want to kind of look at these equations and say like, all right, which one of these is going to be the easiest to solve for one variable? So we can either choose to solve for x or to solve for y. So if I look at this first one, if I solve for x, I'm going to have to move the y over and then I'm going to have to divide by that coefficient. If I solve for y in this first one, I'm going to have to move the 2x over and then I'm going to have to divide by this coefficient. In the second one, if I solve for x, I move the y over and divide by the coefficient of 2, or I can solve for y by just moving the x over and then there's no coefficient that I have to worry about. So I'm going to solve for y because it's going to be easier because y is already by itself. So how I'm going to do that is I'm going to say, okay, y equals, I'm going to subtract this 2. So I have negative 2x plus 9. All I did was I solved for that variable. I got y by itself. I isolated it. This is your step 1 from up here. Now that I have that, what I'm going to do is I'm going to go ahead and plug that whole thing into this equation here for y. So what's going to happen is we're going to take, and I'm going to rewrite this whole equation, but I'm going to plug in this in for this y. So instead of using a circle, I'm going to use the parentheses. I tend to use color because then I can really see what's going on. Hopefully my son doesn't knock this over. So I'm going to rewrite it. I have 2x minus 3, and then I'm going to put in parentheses this whole piece right here. And that equals, woo! Yeah, it is yours. Give me 1 second. And that equals negative 11. Okay, so we have to distribute this. So we end up with 2x minus, this becomes 6 because negative 3 times negative 2 is negative 6x. And then negative 3 times 9 is negative 27. That's all going to equal negative 11. Now I'm going to solve for my variables. So first thing I'm going to do is I'm going to combine my like terms. I get 4, I'm sorry, that's a plus. 8x minus 27 equals negative 11. And now I'm going to go in and I'm going to add 27 to both sides. I get 8x equals 16, so x equals 2. This right there is one of my solutions. So now what we're going to do is we're going to go in, because we said that y equals this, we're going to go into our original equation that we started plugging things into, but now we're going to plug in that x equals 2. So what we're going to do is we're going to come up and substitute this x. So I have 2 minus 3y equals negative 11. I'm going to plug in this 2. Are you seeing where this is coming from? So now we're going to go ahead and solve for our second variable, which is y. So 2 times 2 times 2 minus 3y equals negative 11. 2 times 2 is 4 minus 3y equals negative 11. I'm going to subtract the 4, negative 3y equals negative 15. Divide by negative 3, y equals positive 5. Now we're just going to check. So the easiest way that I check is I bring both of my solutions. So I'm going to use this brown color. I'm going to bring this, and I'm going to bring this, and I'm going to plug it into this equation. The reason that I'm going to plug it into this equation is because I've done all the rest of my math with this first one. So we're going to use those two, and we are going to substitute in. Sorry, my son is jumping. So we're going to substitute both our x and our y. So we end up with 2 times x plus y equals 9. And we said that my x was 2 and my y was 5. So when I simplify, 2 times 2 is 4 plus 5. Does that equal 9? Yes. So then our final solution, the way that we write it, is in ordered pair, and we're going to put it in xy. So we say 2, 5. So there you go. I'd like for you to do this one right now. Pause it, come back, and check your work. Okay, so real quick, I chose to solve for y on our first equation. So I got y equals negative 2x minus 2. I plugged that in for my y value in my second equation, and then I just kind of went down. There you go. So I got 2 and negative 6 as my answers. Now, these next two, one of them has an infinite amount of solutions and the other one has no solution. One is a parallel line, and you'll be able to see that by looking at the slopes. And the other one is the same line, and if you substitute, you'll kind of figure that out. Or once we simplify, you'll kind of figure that out. So first thing that I'm going to do is I'm going to choose one to solve for y. So I'm going to choose this second one because y is by itself. So I'm going to subtract 2x. I get y equals negative 2x plus 18. Now I'm going to go ahead and plug that in for y up here. So I get 6x plus 3 equals 54. We're going to go ahead and plug that in. So we end up with negative 2x plus 18. Okay, so once I go through and kind of simplify this, I end up with 6x. 3 times negative 2 is minus 6x. 3 times 18 is 54 equals 54. Well, you can already start to see that something funky is going on here. So what happens with this one is this. When I combine these like terms, I get 0 plus 54 equals 54. So I end up with this like 54 equals 54. So I don't have a variable anymore. So what ends up happening with this is it means it's the same line. So there's not necessarily one solution. We have an infinite amount of solutions. All right, last one. So this time I'm going to solve for x first because x is the one that doesn't have the coefficient. So I'm going to subtract 5y from both sides. I end up with x equals negative 5y plus 4. So this time we're going to plug everything into x. So we're going to get 3 times x plus 15y equals negative 1. So then I'm going to go ahead and negative 5y plus 4. We're going to do distribution property. So now we get 3 times negative 5 is negative 15y plus 3 times 4 is 12 plus 15y equals negative 1. Well, now this time you can see something that's not going to work out either. So what happens when I have this negative 15y plus this plus 15y is I get 0y again plus 12 equals negative 1. So we get 12 equals negative 1, but that's not true. 12 doesn't equal negative 1. So notice here we have a 54 equals 54. So that's the same line. This way right here, this is two different lines, but they don't equal each other. I can't do this. And so what ends up happening is this one is a parallel line. And I'm going to show you how we can check this. So this has no solution, but let's go ahead and figure out how we can check this. So when we simplified for x, but what we should do is we should simplify for y and look at what our slopes are of both of these, because we want to make sure that we have same slopes. So I'm actually going to extend this line because we're going to check, we're going to check both of these and make sure that they have same slopes. If they have the same slope, there's not a solution. They'll never meet. So this first one we have is x plus 5y equals 4, and then we have 3x plus 15y equals -1. I'm going to solve both for y and then check my slopes out. So I'm going to subtract x. I get 5y equals -x plus 4. Divide everything by 5. We end up with y equals -1/5 x plus 4 over 5. And that's fine. It doesn't need to be perfect. On this side, we're going to subtract 3x. We get 15y equals -3x plus -1. I'm going to divide everything by 15. So I end up with y equals -3 over 15 plus -1 over 15. Oops, sorry, I forgot my x. Now I can simplify this, and what you might notice right away is that we end up with that. And when you end up with that, and you have those same slopes, we know from our last unit that same slopes equals parallel, so there is no solution. All right, so we've done an example now, 2 examples with 1 solution, an example where there's a same solution. So a note that you might want to write yourself is when you have a number that equals a number, if it's a true statement, but you no longer have a variable, it like cancels out the variable, it's the same line, so there's an infinite number of answers. If you work through and you end up with 2 numbers and no variable that are different, what that means is that you have 2 different lines, but they're never going to touch. They don't have any intersecting y's. They don't have any intersecting x's. Here, this is where it's intersecting. This one, it's always intersecting. This, it'll never intersect. So 1 solution, infinite solutions, no solution. On the back side, we have just a couple of little questions. When should you use substitution over graphing to solving systems? This is really just like if the problem tells you, if you don't have graph paper and you don't have a calculator. So now I have a couple of different word problems, and basically what you have to do with the word problems is you have to figure out the 2 different equations. So this says that Showplace Lanes charges $4.50 per game as well as $3 for shoe rental. So we know that Showplace Lanes, we have $4.50 per game, plus $3 for shoes. And Westgate Bowling charges $4 for game and $4 for shoes. So it doesn't matter if I play 15 games, 2 games, 1 game, I'm also going to always have to get charged this $3. Same with down here. So now it says, so we got this equation was right here. And then the second equation was right here. How many games must be bowled before the price of bowling is the same? So what we're going to do is we're going to find that system where this is the same. So basically both of these are set up in y equals. So this first one is y equals 4.5x plus 3. And then the second one is y equals 4x plus 4. So I'm going to go ahead and I'm going to substitute this whole thing right into here. So we end up with 4x plus 4 equals 4.5x plus 3. Now when I start solving, I'm going to, I think what I'm going to do is I'm going to subtract 3. So I get 4x equals, doesn't equal, plus 1. Oh my gosh, I can't do math right now. Equals 4.5x. Now I'm going to subtract the 4. So I end up with 1 equals 0.5x. And then we're going to divide by 0.5. So x equals 1 divided by 0.5 is 2. So this means at 2 games, it's equal. So how many games must be bowled before the price of bowling is the same? 2 games. And what's the cost? We're just going to go ahead and plug this in to any of these and solve for y. And I did not do a very good job. I'm going to have you guys do these 2 by yourself, and we'll talk about them tomorrow anyway. So I'm going to just come over here and use this space. So what I end up with is we get y equals 4.5 times 2 plus my $3 bowling shoes. So 4.5 times 2 is 9. So my total cost is $12. All right. I'd like for you to give these 2 a try. I will help you out by helping you come up with the 2 equations for both. But then I'm going to have you do the rest by yourself. So a local service organization is wrapping gifts at the mall to raise money for charity. Yesterday, they wrapped 20 small gifts and 20 large gifts, earning a total of $166. Today, they wrapped 19 small gifts and 47 large gifts and earned $348. How much did they charge for each sized gifts? Okay, so what is happening here is this. We have 26S plus 20L equals this. So I have 26, and I'm going to use small, be careful with that S, small plus 20 large equals $166. The second one is right here, 19 small gifts and 47 large gifts equals $348. So now we have 19 small plus 47 large equals 348. When you go to solve this, if it's easier, just go in and replace these with the variables that you know. Up on this one, Main Street Florist charges $18 for a dozen roses and $5 delivery fee. Blooms and Bouquets charges $20 for a dozen roses and a $1 delivery fee. How many dozen roses will need to be purchased for this price to be the same, and what is the cost? This one is very similar to this. So we know that Main Street Florist charges $18 per dozen and $5 delivery fee. So Main Street equals $18 per dozen plus $5 delivery fee. Blooms and Bouquets charges $20 per dozen and a $1 delivery fee. So Blooms equals $20 per dozen plus a $1 delivery fee. Again, just change it to the variables you know. Good luck, and I'll see you tomorrow, hopefully.